So first of all, I have to say that Denmark is really dangerous. I was well and healthy when I left home. 2 days later, I have a hard time speaking. So if I talk to not loud enough, then please tell me and I'll repeat what I said. Yes, so I'm going to, as the final talk, I'm going to give you a vision of what I hope will be the future. And I call this a haskell-suite. And yes, this is work in progress and ideas, a lot of it. First of all, before I say anything else, let me make this perfectly clear. Simon, yes, this is for you. Okay, I like GHC. GHC is by far my favorite piece of software from any kind.
I didn't quite hear you.
Okay, you suck it up now, because what I'm going to say in the rest of it.
I'm playing your photograph.
Alright, so, anyway, what I'm going to say for the rest of the talk is not really criticism per se, it's just the criticism of love. Wanting things to be perfect. Alright, so, what is this vision I have? So the haskell-suite, to me, is a modular set of libraries which together would comprise sort of a Haskell implementation, meaning going everywhere from parsing program down to, well, basically running it on some platform somewhere. But for some definition of complete implementation, because I wouldn't want to do all of these things. So each library that would make up this suite would support fine-grained and very explicit operations on some part of this tool chain, so that the users, the clients of this tool suite would be able to pick exactly the operations that they need for their particular application. Be it parsing, be it code transformation, be it type checking, interpretation, whatever. And the focus of this would be providing this very fine-grained and explicit interface, so that you can really do exactly what you want, get exactly the functions that you need, and not try to be another optimizing compiler. Right, so I see lots and lots and lots of cool use cases for this, and I hear even more use cases from people I talk to when I mention these ideas. So, code transformation, well, you want to write your own custom extension. Right now, what will you do? Well, you will go and branch off GHC. That's a big task. I want to make that easier. Preprocessors, yeah, I have at least one of my own. No, I have two of my own. We can imagine refactoring. I know Roman is going to give a lightning talk on something very interesting here in a while. This. For IDEs, well, some might want to do syntax highlighting, and you just want this token string basically, but maybe something more than that. Type checking for tooltips, finding, well, name resolution, finding the definition sites of values, doing some sort of code analysis, well, yeah, lots of things. DSLs, for instance, was mentioned here before when during the talk by Sylvestra on JavaScript. Chris Dunn's Fay library is looking to use this to do domain-specific type checking, domain-specific preprocessing, to generate JavaScript, or rather to write JavaScript and generate Haskell code, which will again generate JavaScript. Someone mentioned to me that this would be cool to use for lightweight embedded Haskell functionality to be called from other languages or other programs. I find that cool. But also, these are just, you know, every time I talk to someone, they give me a new cool idea that this would work for. So I'm sure there's lots that is not on this slide. So when I mention this, some people suggest, well, okay, so why don't you go and just remake GHC into what you want? I mean, okay, so the GHC API, which is your hooks into the GHC internals, that's really the current alternative. That's what you need to turn to if you want to do any of these things. Right now it's very monolithic, meaning if you want one piece of this, well, you're going to link in all of GHC into your program. It's opaque, well, that's very subjective, but okay, people usually turn to me and say, okay, please give us something better so that we don't have to blow our minds trying to understand what the GHC API actually does. Unfortunately, I know it's been improved in various ways, but I still think the third point here is the most important one, namely the GHC API is sort of, well, giving you hooks into what is really the real thing, the highly optimizing, awesome compiler. But that's what the main goal is. GHC API just lets you go in at different places and do cool things with it, but that's not the primary objective. And this, of course, affects the two other points. It becomes monolithic, it becomes opaque. Also, which Atze also mentioned slightly, that GHC right now is sort of defining what Haskell is and what's needed in order to be considered a Haskell implementation. And I find that unfortunate. Partly because it's harder for other implementations, not necessarily full-fledged implementations of compilers, but any implementation working at any spot along the tool chain. But also because it lets GHC cut corners and cheat and do take design decisions based on what would be best for GHC and maybe not what would be best for Haskell. And I also think, so UHC is certainly a competitor, but maybe, I mean, it doesn't operate in the same scale. So I think if this haskell-suite would come with sort of a different angle, a different approach, it would be an entity with completely different concerns as to how things should be designed for the front end. And that would be a plus. It would sort of be a contention that would force more clear, make the design more clear and concise. So I was going to say here that GHC really is Haskell, and make the connection to UHC. Now, actually, I already talked about that, but I was going to say that since I maintain the haskell-src-exts library, I get bug reports, and every so often I get bug reports that say this works in GHC, it doesn't work in haskell-src-exts. Clearly a bug in haskell-src-exts. Okay? Not, well, 9 times out of 10 it is. I have to fix something. 1 time out of 10 it is a bug in GHC. It's most often the same bug in GHC. I will talk about that in a while. I was also going to say that I never get anyone to tell me this works in UHC. Maybe it doesn't work in haskell-src-exts. But actually, just this week, last week, someone did tell me this works in UHC. It doesn't work in HCC. So I was glad to hear that. It was one of the UHC developers. Still, I still think it's a step in the right direction. Okay, so this is the Haskell suite, as I envision it. Well, at least it's the start of the Haskell suite. Might be more things. At the base here, it would be the haskell-src-exts package, which today works and provides parsing functionality, AST, traversal functionality, pretty printing, exact printing. Basically everything you want to do with your source code without going into semantics. Then you would need name resolution, input chasing, scope analysis, which would be able, well, we could put that in a separate package. You could use that if you need it. Most larger applications would. And I often hear requests for having this kind of functionality. Then you would have type checking, to be able to go in and just say, okay, I have this syntax tree, give me, what's the type of this? I've also written sugaring there. Turns out that that's both easy and very useful for lots of other things here. But really it's one example of, in this case, a very useful transformation. But we could imagine other modules here doing other kinds of transformations on that syntax tree. At the top, well, it would be really cool to have an interpreter. I'm sure lots of applications will be able to make use of that. And also, well, hey, I have an AST and I have a parser and I have a pretty printer. You know, it's almost like template Haskell. It has all these things as well. Why don't we do meter programming as well? That would be nice. So that's sort of a dream. And also, here be code generators. I don't really plan on writing those myself. It wouldn't be really part of the vision, but of course it would be part of the vision to be able to support whatever code generation you want to do. So, this is the vision, and for a very long time, this has been my vision, and for a very long time, this bottom line thing here has been the reality of things. But things are actually starting to happen right now. So, this is still, well, mostly working. I haven't really updated to GHC 7.6 yet, but I will, I promise. Lennart gracefully supplied, well, Haskell modules, I believe it was called in Lennart's version. A package which does most of what we need for an English solution. Some of you may have seen that we had a Google Summer Code project run by Cheyenne, trying to implement type inference on top of this. And he, as a part of that, he actually implemented what would be the desugaring module. So, on the top there, it's all blank still. For the interpreter over here, at least I know what I would like to do. So the outline is clear, but for meter programming, it's not a cool thing. So the level of greenness should sort of indicate how ready it is, how mature it is. So let me have a look at these then. So haskell-src-exts, I'm sort of assuming that you know it. That's very humble of me. But okay, so it's a library for Haskell source code manipulation. And it's, well, it was conceived and built originally in 2004, I believe. And I put it up on Hackage back when Hackage was created. And I would like to state that I've actively maintained it since 2006. I think at least Lennart would like to object slightly because there's been some dips. Mostly to do with large peaks in my day job, like PhD thesis and those kinds of things. But I hope I'm stepping up again. Haskell-src-exts is almost compatible with the GHC. Before GHC 7.6 it was this close. But I haven't added the syntactic extensions for 7.6 yet. Also almost compatible. Well, there's this bug, you know, so I don't always want to be compatible. Okay, so as I mentioned, Cheyenne did this Google Summer Code project. I suggested a project doing a type checker on top of haskell-src-exts, which would implement the extensions from GHC. Well, I didn't say all the extensions. I said JDTs and rank n types, because those were the things that needed extra attention in the structure when you build this type checker library. But as China started working on this and started communicating with potential users, it was quite clear that what people wanted the most was a full-fledged type inference engine that supported Haskell 2010. Never mind the rest, we can add that later. Okay, so that's what Cheyenne did. So the result, which I believe he hasn't fully released yet, but he has promised more than once that he will, is a type inference engine for supporting Haskell 2010, but where focus has been put on the structure for how to extend this further, and we certainly intend to do that. There's one caveat here: he doesn't support record syntax. That's not because it's really difficult, but because he hates it. Okay, so Cheyenne intends to continue to do this, and I intend to support him doing that. Okay, and then there's this names package, which was supplied to us by the world's best programmer, which we heard yesterday. And of course, that means it's an awesome library. Okay, and it is an awesome library. So when Leonard sent this to us, he said it was 90% complete, and it was several years ago since he had done it, so he no longer remembered anything about it. So we've had to dig into it and see what's actually there. And it's really nice. So thank you very much.
But 90% of the work is always in the last 10%.
Well, that depends on what the 90% means. I think you did a pretty good job there. So hopefully it won't be all that long until we actually have a complete name resolution engine to supply for this. All right, so just briefly about the other parts. Well, an interpreter. My idea is very humbly to sort of be something of a reference implementation of what's written in the report. So it won't be the fastest. GAC will be the fastest, of course. But hey, people use other languages and they're not fast, so we can do interpretation too. Meter programming, yeah, as I said, we have all these building blocks. And if I wanted to support sort of template Haskell, well, why would I want to go to a different syntax tree to do that? Template Haskell is still experimental, so I can experiment here. We'll see who does the best thing. And yeah, desugaring, as I said, it turns out it helps a lot of the other parts, and it's also a nice example of how to do transformation. So, what then? Okay, this is a very ambitious task. I'm suggesting to implement all of Haskell. But I think it's also an important task, and I think the reactions that I get from people when I talk to them about this really suggest that it is an important task. It might not be important in the way that FP Complete would say is important to the industrial users, but I think this is something that's really important to the library developers. And in the extension might then lead to a number of cool tools that would really help industrial developers. I think Roman's tool is one good example of that, so I'll advertise that a bit more. But yeah, making this vision into reality, well, we've gotten some part of the way, but there's still a lot of resources to be made. To be needed. And of course, if you think that this is a cool project, and if you want to support this dream to become reality, then please contact me, please help out. Also, a long time wish of mine is to get rid of that silly old haskell-src package. It's buggy, and it doesn't support everything it should, and I don't see where people use it. But so this is partly why I asked about licensing for that platform, because there might be some intricate details there that would have to be sorted. All right. That's me.
can you please port some of that typing point stuff over to template Haskell? I say this as someone who has used template Haskell to do some things, and I really needed those sorts of things.
Well, I mean, I will supply the type inference things. So whoever is maintaining type template Haskell might be the one who should ask those things.
Can I say something about that? So I maintain template Haskell.
Yes.
I wish somebody else would.
I just want this for like Thomas.
Thank you for mentioning that. So one of the things that's always bugged me about template Haskell is that we've got the big syntax tree for Haskell that GHC uses. It's called HSSyn, as many of you will know. It has many data types, and it's meant to be GHC specific, unashamedly so. Then there's the template Haskell data type, which is the whole big syntax of Haskell all over again, but meant to be less sort of, GHC hackish, meant to be more the kind of thing that somebody who's generating syntax trees might want to do.
Right.
And then there's haskell-src-exts as well. So it's always struck me as this is stupid. The latter two should really be the same. Right? It doesn't really make sense to have 3 representations of Haskell source code. So I would really like to use the Haskell source-exts data for template Haskell, or vice versa, or make some union of them. But I'm not prepared to sort of lead on that unification. And then there'd be a certain amount of existing template Haskell users who would be distinctly discharged, but people in Haskell programmers are used to that. That doesn't make sense to have these 3 big data types all representing Haskell source trees. And this speaks to Dan's question, right? Because if template Haskell had that syntax, well then you'd be able to use all the wonderful things that we just spoke about today. So there you go. But yeah.
I totally agree.
Somebody needs to help with that. Actually, it won't matter. Just leave it to me. But I'm just advertising that I'm open to that as a possibility.
I have one comment on what you just said. So the problem currently with, I dabbled in IDE support, so I have some experience with the GHC API right now, and I felt lots of pain using that thing. One of the problems is that you have to basically, whenever you use something that's part of GHC, you have to adhere to GHC's release cycle. So whenever you want a new feature to get in, you have to wait a year until. Having something separate also completely decouples the release cycle, which makes it much easier to work with.
I wanted to respond to the comment about whether this was relevant to commercial users or to FP Complete. When you hear your organization name, you always have to say something. I think it's very relevant indeed. Those of you who've been online a bunch this week might have seen that Michael Steinman has started a discussion with various other people doing IDE work, and those who work on IDEs and haven't seen it might want to contact Michael or me. We think it's terribly important for commercial users to have code introspection features and all the interactive capabilities that leads to, and having proper API access that's properly maintained, as well as in proper release cycle, as well as focused on people writing tools. It's just terribly important for that. So I think this is wonderful. I won't speak to what the final API should be when everyone works together, because I'm neutral on the issue, but this is important stuff and valuable.
Great.
So this sounds really great, and I'm looking forward to it. But you showed these possible applications, and it seems that there is a tension between applications which want a really good interface to an exact implementation of Haskell as it is, and these other applications which really want to extend Haskell. And they want to have like an open AST and an open type checker, they want like add different constraints, and they want to have this extensible rewriting engine and all this kind of stuff. And this would be really cool to have like, I don't know both of it, but everything I see on extensible ASTs in Haskell is not exactly, well, programmer friendly, let's say. So how will this tension be resolved?
So I totally agree with your point, and I've been actively following what's happening with the extensibility for a lot of years, wanting to have something like an extensible AST, because I think that's a crucial point, how to make an extensible AST relevant. For this project, we're definitely going for the former alternative. because there are no sufficiently mature extensible solutions. So we're going for a fixed AST, and if you want to experiment with extensions, which I hope you do, because that's really fun, then you have to fork. Right? I mean, it's still better than having to fork GAC, I hope. And in the future, I totally agree, I would love to see something extensible as well. And even better if the two could coexist. But yeah, that's still shrouded in mist.
All right, let's thank Niklas.